Good morning, dear boys. Welcome back to social science class. Dear students, in our previous class, we had a discussion on a topic, the Earth, our living planet, continuing with the same, taking the same concept today. Let us start from a topic, longitude. In our previous class, we have come across two important aspects. Number one, about distribution of the land and water bodies, and also we had a discussion on latitudes. And today, let us have a discussion on longitudes. Dear boys, longitudes and latitudes are an imaginary line that drawn on the globe in order to locate the place, to know about the time, distance from one region to another region. For all these advantages or for all these uses, we have demarcated these imaginary lines. Longitudes, it is an imaginary line that are drawn on the globe from north to south direction, which intersects 0-degree equator. So this is what we call it as a longitudes. Here is the diagram. Longitudes are in imaginary lines that drawn from north to south. Drawn from north to south that intersects the 0-degree equator. The blue line which I have written here, it is called as 0-degree equator. Isn't it? Yes. As I told you, longitudes are the series of a semicircle. You can see only half of the circle here. This is a semicircle. It is a series of semicircle that runs from north to south pole passing through the equator. Isn't it? The passing through the equator from north to south direction. It is passing from north to south direction. And all these lines that passing through the north to south direction, all these lines are of the same length. You can see here, all these lines are of to the same length, and these lines are called meridians. These lines are called meridians. What do you mean by meridian? Meri means mid. Dians means day. So therefore, meridian means midday. That means to say here, dear students, because of all the places along with the same meridian, that lines that what we are seeing from north to the south direction, the same meridian of longitude experience noon or a midday at the same time. They experience noon or the midday at the same time. Hence, we call it as meridians or midday. That means every longitude that experience that midday, the sun rays that fall vertically on it and that experience noon or meridian, that is midday. So this is a point to keep in mind. Coming to the next very important concept, here you can see the center line that is colored with orange or a saffron color. You can see here, this line we call it as a central meridian. Central meridian can also be called it as prime meridian. It is also called it as Greenwich meridian. It is called by three different names: central meridian, prime meridian and Greenwich meridian. All these are the same. That is a central line that passes through the line. What is this? Why we call it as central meridian? See, in order to demarcate the latitudes and longitudes, the first line that we have to draw on the globe, and that the first line we call it as 0-degree meridian or central meridian or prime meridian. As I told you, it is also called as a Greenwich meridian. And this line that passes through a city called Greenwich City, which is in England, or that is the Greenwich City in England that passes through it. Why it is in England? Why we have taken that country as a central meridian line? Why can't it be India or Australia or America. Why not we have taken that nations to demarcate this? No, you can draw this central line or any line that you can draw, first that can indicate as a central line. But here, why we have taken England? Because somewhere it was in the year 1884, all the geographers all over the world, they all have met in England, that is a Greenwich city. They all came to England for the Greenwich city, and they all have assembled in a place called Old Royal Observatory. It is a hall, the discussion hall. The Old Royal Observatory that was in Greenwich city, which is in England, they all have come and met there from the different corners of the world. There's so many geographers, they came and discussed related to this latitudes and longitudes, standard time, local time, and as well as the international date line, all these issues that they wanted to discuss with. So therefore they all have came and met in that place. So in the memory of it, they have taken that line or that city itself as to passing through the 0 degree meridian. So therefore the London city is what we call it as a 0 degree meridian. Yes, this 0 degree meridian that passes through a Greenwich city in London, or that is in England, there are 180 longitudes that passes to the east and 180 to the west. So therefore there are 360 longitudes on the globe. How many longitudes are there? There are 360 longitudes, 180 to the east and 180 to the west. Here I have written there are 180 longitudes to the east and 180 to the west. So in total we can say there are 360 longitudes. Here the 180 longitude to the east, this part, the eastern part, and we call it as an eastern hemisphere. The western part we call it as western hemisphere. Just like how we have taken northern hemisphere and southern hemisphere while discussing on a topic latitudes. Coming to the longitudes, we have eastern hemisphere and the western hemisphere. 180 degree east we call it as eastern hemisphere, 180 degree west we call it as the western hemisphere. So these are the points to keep in mind, dear students. You know, the distance between one longitude to another longitude is of equal distance at the equator. I'll come again. The distance from one longitude to another longitude. Here I have demarcated 30, 60 and 90. Here also 30, 60 and 90. The front face of the earth, here you can see 180, 90 to the east and 90 to the west, in total 180. If you go to the back side of it, you are seeing only the one side of the globe. The back side of the globe, again it takes 90 and 90, 180. So front 180, back 180, totally 360 degree you can see here. So therefore, here from one longitude to another longitude, there is a distance of 111 kilometers. See here. If you take this as one longitude, I'll call this as a 0 degree, that is a central meridian. This is what I can say 1 degree. Like that we have 360 degree, 180 to that side and 180 to this side, that is east and west. From one longitude to the another longitude, what is the distance? What is the distance? 111 kilometers. 111, that is 111 kilometers. It's a distance from one longitude to another longitude. Very important point to keep in mind. So therefore, it is equal distance when it is in the equatorial region. As you move towards the polar region, as I told you, it is a semicircle. As you move towards the polar region, the line, what you can see, it becoming smaller. It becomes small. Once you touch to the 90 degree, yesterday I told you, this 90 degree is just a point. It's just a dot. So when it reaches to the 90 degree, it is just a point. So all these lines, that meets to the 90 degree north and to the 90 degrees south as a point. As you proceed to the polar region, the distance from one longitude to another longitudes, that keeps on decreasing. So this you have to keep in mind as one of the most important point, dear students. So all these are connection with the longitudes, and now we shall move on to another very important concept. It's all about longitude and time. What is this longitude and time? Here we have a small mathematical calculation. I'll come to that. Before that, please take down the concepts that in your rough notebook or in a scribbling pad, whatever that you are listening or whatever that I have written here, make a note, isn't it? Next, we shall move on to another concept, longitude and time. I think if you have taken this, I'll erase this. Longitude and time. Yes, dear students, there is a definite relationship between longitude and time. A few minutes back I told you latitudes and longitudes are an imaginary line that we have drawn to know the place, exact place and the time of that particular place. So when we are talking about this time, obviously the time is calculating based on the longitudinal thing. So therefore, longitudes and time, they have a definite relationship. Yes, the earth, as you all know, that it is rotating on its own axis. It's a 5th standard concept you all have learned. It is just like a spinning top. It is rotating on its own axis, isn't it? Yes. It completes one rotation in a day. That means 24 hours. Earth takes 24 hours for one rotation or its one rotation. Here it gives rise to the time that differs from one region to another region. As I told you, there are 360 longitudes on the globe, isn't it? There are 360 longitudes on the globe. The earth rotates on its own axis and it takes 24 hours for its one rotation, and in order to complete a day, that means the sun rays that touches all 360 longitudes. To complete this 360 longitudes one circle, it takes 24 hours, or we can say it as one day. What is the time gap from one longitude to another longitude? Just now we had a discussion on the kilometers. From one longitude to another longitude, the distance is 111 kilometers. And what is the time? We have to calculate the time now. So therefore, here as I told you, simple mathematical calculations that we need to focus here. Longitude and time have, there is a definite relationship, have a definite it is having a definite relationship. Earth takes 24 24 hours or hours to complete what? To complete one rotation. To complete one rotation. About this rotation and revolution, you have learnt in your previous level. Earth takes 24 hours to take one rotation, and revolution, Earth takes 365 and a quarter days to complete one revolution. That we call it as a year. Yes. You know, there are 360 longitudes on the globe. There are 360 longitudes on the globe. From one longitude to another, from one longitude to another longitude, there is a time gap. There is a time gap of how many minutes? 4 minutes. There is a 4 minutes. This line that we indicate as a minutes. You know, degree means this is how we consider it as a degree. Say for example 4 degree. But when we take it as a minutes, this is how we need to refer in our geography. 4 minutes. From one longitude to another longitude, the time gap is of 4 minutes. Now, let us have one simple calculation. 360 longitudes, from one longitude to another longitude, there is a time gap of 4 minutes. Now, we shall have a calculation, a small calculation. 360 into 4. What is this? 360 degree. From 1 degree to another degree, 4 minutes. So, 360 into 4, what is the, do some small multiplication here, you will get 1440. This is the answer you will get. 1440. What is this? Minutes. 1440 minutes. Here also it is a minute. There are 1440 minutes. If you want to convert this minutes to the hours, what you have to do? You have to divide it by 60. 60 minutes is equal to 1 hour. So, therefore, you have to divide it by 60. As you know that 60, 24. 61 are 60, 24 are 1440. That is 1440 minutes. So, therefore, what is this 24? 24 hours. This we calculate in hours. I will demarcate with a different color. This is 24 hours. That means to complete one rotation, it takes 24 hours. This is a small calculation that you need to keep in mind. See, on the globe, it is very difficult to draw each and every degree. So, therefore, we have taken a gap of 1 hour. What is the gap of 1 hour? There is a 1 hour gap is equal to 15 degrees. Say for example, this is 0 degree. Then we will take this to 15 degree. Then we will go to 30 degree. But here I have taken the gap of 2 hours. Got it? Here it is a gap of 2 hours, and here I have taken to the 1 hour. That means how can we calculate? It's very simple. 15 degree is equal to 1 hour. 15 into 4. 15 fours are. 4 5s are 20. 1s are 4. 5 6. 60. 60 minutes. So, 60 minutes is equal to 1 hour. So, there is a gap of 1 hour, 15 degree. It is easy to calculate on the globe. So, therefore, 15 degrees is equal to 1 hour. Like that, 30 degree means 2 hours. Then you go for 60 degree means it is 4 hours, 30 to 60, double. So, it is 4 hours. Like that, here there is a time gap in such a way. Here also we have taken, that is 360 degree into 1440 minutes. Here we are calculating this into minutes, and minutes we are converting into hours. And here also this minutes we are converting into hours. If you want to take 1 hour, there is a time gap of 15 degrees. That is 15 degrees is equal to 1 hour. So therefore, all these are the points that we need to focus, my dear students. And here, you know, a very interesting thing. East, when you move towards, we use this word east gain day, west lose day. What is this east gain day and west lose day? Or once travel from west to east, he will gain a day. The one who travels from east to west, and he will lose a day. About this, I will not discuss in this class. While discussing on the international dateline, we will have a discussion on this particular concept, because it is more relevant when we discuss at that time than this hour. We will discuss this in our next class, in the upcoming class, when I will take this international dateline. This is the last concept of in this chapter, international dateline. While discussing on that time, we will have a thorough discussion on this east gain and west lose day, that we shall have a discussion in our next class. Yes, my dear boys, all these are the points that you need to be focused. And we have another very important thing here. Just now we have discussed on the longitude and time, and now we shall move on with a small concept, that is a local time. You know, what is this local time? What is this local time? It's very simple. You know, the time according to the longitude of a place that shows the 12 noon, whenever the sun is at the top of your head. When the sun is at the top of your head, that is what we call it as a local time. That is a midday of that day. Madhyana anta heltivala. When the sun is at the top of your head, that we call it as the local day. Here the 12 noon at every place, whenever there is a 12 noon at the top, that is what we call it as a local time or a local place. So these are the points to keep in mind. And next, in my next class, I will discuss on another important concept, that is standard time. How this standard time is different from local time. First of all, what is actually the standard time explains about how we calculate this standard time. Do every country have this standard time? Yes, all these concepts that we shall have a discussion in our next class. Until that, we'll take a break. Thank you, dear boys.